Okay then, Year 12, we're going to be looking at geometric sequences and series. So just like the arithmetic progressions, arithmetic sequences we looked at in C1, this takes us on to the next step. Now the good news is we are given a load of formulae. Okay, we're given these formulae in your formula sheet you'll get in your exams. So you don't need to learn these rules, but it's very important we learn how to use them. So we'll learn what A stands for, what R stands for, and N stands for. Also at the same time what UN and SN stand for. So in the first part we're going to be looking at recognising a geometric sequence and stating its common ratio. So, first of all, geometric sequences come up in loads of places. When you're older you'll go on to get mortgages. That's an example of a geometric sequence. You'll also get loans, exactly that's the same, but also interest on bank accounts is a geometric sequence. Okay, so there's lots of examples of this in real life. Start off with the main crux of what we're going to be looking at is the common ratio. Now this is simply, instead of an arithmetic sequence where we add on something every time, in a geometric sequence we're going to be multiplying by that same number each time. So this is the common ratio. So as we can see in the first sequence here, 1, 2, 3, 4, 5, 6, 1, 2, 4, 8, 16, we're doubling. So we're multiplying by 2, so the common ratio is 2. If we look at the next one, 100, 25, 6.25, 1.5625, we're dividing by 4 each time. So the common ratio would be 1/4. We're multiplying by 1/4. This common ratio doesn't always have to be positive. If it's negative, it has the effect of making the sequence go positive, negative, positive, negative. So we get this example like this: 2 minus 6, 18, minus 54, 162. So each time we're multiplying by -3, so the common ratio is -3. Now the easy way to find the common ratio is to simply divide one term by the previous term. So if we look at the first example here, example A, if we take 10 and divide it by 2, we get 5. The common ratio is 5. Similarly, if we take the third number in the sequence and divide it by the second, again, we get 5. And in fact, if we take any term, so 250 divided by 50, again, we get 5. So the common ratio, which we're going to call R in this example, is 5. If we look at the second one, again, the rule is we take one term and we divide it by the previous term. So here, this simplifies down to -1/3. So the common ratio is going to be -1/3. But if I just show you another example, so 10 divided by -30 again is -1/3, as is the final one. So in this case, R equals -1/3. So you should be able to go on now and have a look at the first example, exercise 7a, which is basically just focusing on this.